Hi, I'm Dr. Jagluri, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, we shall solve some problems which is in superconductors. So, the problem, the transition temperature for plumber is 7.2 degree Kelvin. However, at 5 degree Kelvin, it loses the superconducting property if subjected to magnetic field of 3.3 into 10 power 4 ampere per meter. Find the maximum value of H magnetic field which will allow the metal to retain its superconductivity at 0 degree Kelvin. So this is the problem. So let's solve the problem by writing all the given data. So that given data is transition temperature of plumb. So transition temperature or critical temperature. So transition temperature or critical temperature may be termed as at which temperature the normal conductor converts into superconductors. So the transition temperature of plumber Tc is equal to 7.2 degree Kelvin. Whereas critical magnetic field, the critical magnetic field, that is here when this plumber is subjected to magnetic field, it loses its superconducting property at 5 degree Kelvin. So at 5 degree Kelvin, it loses the superconducting property if subjected to magnetic field of 3.3 into 10 power 4 ampere per meter. So this is the critical magnetic field. So critical magnetic field, at which magnetic field the superconductor converted into normal conductor. So that is when goes on applying the magnetic field at some particular magnetic field, the superconductor converted into normal conductor. That is, the superconducting property completely destroyed and converted into normal conductor. That is critical magnetic field. So the critical magnetic field Hc is equal to 3.3 into 10 power 4 ampere per meter. The temperature T is equals to 5 degree Kelvin. So we need to find the maximum value of magnetic field which will allow the metal to retain its superconductivity at 0 degree Kelvin. So this is what we have to find. So the formula, critical magnetic field Hc is equals to H naught into 1 minus T by Tc square. So for critical magnetic field, this is the formula. So we need to find the maximum magnetic field at 0 degree Kelvin. So the maximum magnetic field at 0 degree Kelvin, H naught is equals to how much? So H naught is the critical magnetic field at 0 degree Kelvin. H naught is equals to wanted to find. So from this, we can write Hc by 1 minus T by Tc square is equals to H naught. So that H naught is equal to critical magnetic field on 1 minus T by Tc square. This is the formula. So let's substitute the values of Hc, T and Tc. So Hc, critical magnetic field, 3.3 into 10 power 4 ampere per meter. So T is 5 degree Kelvin and the value Tc is equal to transition temperature or critical temperature 7.2 degree Kelvin. Let's substitute in the values. Hc is 3.3 into 10 power 4 divided by 1 minus 5 by 7.2. That is H naught is equals to Hc by 1 minus T by Tc square. So 3.3 into 10 power 4 divided by 1 minus 5 by 7.2 whole square. So with simplifying this one, we get 3.3 into 10 power 4 divided by 1 minus 25 by 51.4. When simplifying this expression, we get 6.37 into 10 power 4 ampere per meter. So this is the critical magnetic field at 0 degree Kelvin. So up to this magnetic field, the plumber to this magnetic field, the plumber be retained in its superconducting property. So the maximum value of H at 0 degree Kelvin is 6.37 into 10 power 4 ampere. In the next program, the critical field of niobium is 1 into 10 power 5 ampere per meter at 8 degree Kelvin and 2 into 10 power 5 ampere per meter at 0 degree Kelvin. Calculate the transition temperature of the element. So, the given data, critical magnetic field is 1 into 10 power 5 ampere per meter, which is Hc. The temperature T is equals to 8 degree Kelvin and the magnetic field at 0 degree Kelvin H naught is equal to 2 into 10 power 5 ampere per meter. So we need to calculate the transition temperature or critical temperature of the element Tc. So that let's write the formula transition temperature again from the expression Hc is equals to H naught into 1 minus T by Tc square. So here Hc by H naught is equals to 1 by T by Tc square. So Hc by H naught minus 1 T by Tc square. So that 1 minus Hc by H naught is equals to T by Tc square. So here T by Tc is equals to 1 minus Hc by H naught half. So we want Tc so that T by 1 minus Hc by H naught power half is equals to Tc. So this implies Tc is equals to T by 1 minus Hc by H naught power. This is the formula which we derived from this main equation, critical magnetic field. So Tc is equals to T by 1 minus Hc by H naught power half. So it is equals to T is 8 degree Kelvin. So 8 divided by 1 minus 1 into 10 power 5 divided by 2 into 10 power 5 whole power half. So calculating this, we'll get 11.30 degree Kelvin. So this is the transition temperature of this element neodymium. The next problem, the critical magnetic field at 5 degree Kelvin is 2 into 10 power 3 ampere per meter in a superconducting ring of radius 0.02 meters. Find the value of critical current. So the critical magnetic field at 5 degree Kelvin is 2 into 10 power 3 ampere per meter. So this critical magnetic field is for a superconducting ring which have the radius 0.02 meters. But we need to find the value of critical current. So critical current IC. We need to find critical current IC. So the given data, critical magnetic field Hc is equals to 2 into 10 power 3 ampere. Temperature T is equal to 5 degree Kelvin. But the radius of the superconducting ring is 0.02 meters. So we need to find the critical current. So the formula for critical current IC is equals to 2 pi R Hc, where I is the critical current, R is the radius of the superconducting material, where Hc is the critical magnetic field. So 2 into pi value is 3.143 into R is the radius which is in meters, so 0.02 meters, into the critical magnetic field Hc is 2 into 10 power 3. So multiplying, the critical current is equal to 251.4 amperes. Next one, a superconducting tin has critical temperature. So the critical temperature 3.7 degree Kelvin at zero magnetic field and critical field of 0.0306 at 0 degree Kelvin. Find critical field at 2 degree Kelvin. Find critical current also if R is equals to 1 meter. So critical current, right? Given data, critical temperature. So critical temperature Tc is equals to 3.7 degree Kelvin, which is at zero magnetic field. The critical field of 0.0306 ampere per meter at 0 degree Kelvin. So H naught is equals to, this is the critical field at 0 degree Kelvin. H naught is equals to 0.0306 ampere per meter. Temperature T is equals to 0 degree Kelvin. Radius R is equals to 1 meter. We need to find critical magnetic field Hc and then have to find critical current for which the radius R is equals to 1 meter. So critical current. So this is the critical magnetic field which is at 2 degree Kelvin. Formula: critical magnetic field Hc is equals to H naught into 1 minus T square by Tc square. For critical current, Ic is equals to 2 pi R Hc. So critical magnetic field Hc is equals to H naught, that is magnetic field at 0 degree Kelvin, into 1 minus T square by Tc square. So H naught is 0.0306 into 1 minus 2 square by 3.7 square. So here Hc is equals to 0.02166 ampere per meter. For critical current, Ic is equals to 2 pi R Hc. So it is equals to 2 into 3.143 into radius is 1 meter into Hc critical magnetic field at 2 degree Kelvin. At the temperature 2 degree Kelvin is 0.02166. So multiplying all these values, the critical current becomes 0.136 ampere. 0.136 ampere. The next problem, calculate the critical current for a wire of lead having diameter of 1 millimeter. 1 millimeter at 4.2 degree Kelvin. The critical temperature for lead is 7.18 degree Kelvin and critical magnetic field at 0 degree Kelvin is 6.5 into 10⁴ ampere per meter. Now the given data, critical temperature Tc is equals to 7.18 degree Kelvin. Critical field at 0 degree Kelvin H naught is equals to 6.5 into 10⁴ ampere per meter. Diameter of the wire D is equals to 1 millimeter. So from this radius is equals to 1 by 2, that is equal to 0.5 millimeter. So the formula to find the critical magnetic field Hc is equals to H naught into 1 minus T square by Tc. For the critical current, Ic is equals to 2 pi R Hc. So critical magnetic field Hc is equals to H naught is 6.5 into 10⁴ into 1 minus 4.2 square by 7.18 square. So 7.18 and then another one is 4.2, that is here temperature is equals to 4.2 degree Kelvin. This is temperature T is equals to 4.2 degree Kelvin. But Tc is equals to 7.18. So substituting, we have Hc, critical magnetic field, is equals to 42.758 into 10 power 3 ampere per meter. For critical current, Ic is equals to 2 pi r Hc. So that is equals to 2 into 3.143 into 0.5. This is the radius. In the problem, they given diameter 1 millimeter. We need to change this into meters. So we need to change this into meters. So meters, so that it becomes 0.5 into 10 power minus 3 meters. So that 0.5 into 10 power minus 3, which is a radius, into 42.758 into 10 power 3 Hc value. So Ic is equals to critical current 134.26 amperes. So this is the critical current. So the references were Engineering Physics by K. Tyagarajan, McGraw Hill Education Private Limited, New Delhi. A textbook of Engineering Physics by M.N. Avadhanulu, Basic Shirasagar, published by S. Chand and Company, New Delhi. Then Engineering Physics by Dr. R. Mugam, which is published by Anuradha Publications, Chennai. Engineering Physics by P.K. Palanisamy, 4th edition, Cited Publications, Private Limited, Chennai. So these are the references for these problems to verify and solve. So we'll meet another topic, the other session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.